Okay, so let's continue where we left off. Yesterday, we did a successful merge of our number one implementation plan. So that one was a refactor of all of the code which we had written by hand. So we wrote a whole bunch of code, both for LangChain, LangGraph, getting all of our Docker components set up, getting a vector database, getting a .NET server, uh, YARP as our reverse proxy into the system. All of that was done completely by hand. But then we said, okay, well, now let's use AI to go and refactor everything, make sure that the architecture is reasonable. And so then we created the implementation plan, had AI go through it, and then the other video, so there was two parts. First part was creating the implementation plan and getting the AI to actually do it. Then once that was done, then going and having it create a document describing everything that it did and having it as a lecture document as well. So I can kind of show you what that looks like here. Hold on a second. So not this one. This one is in the one that we're going to be dealing with today. But if I come here and okay, here we go. If I go to this one, right? So this one was the document that it created saying kind of what it did and all of the things that I should know about, all of the different concepts that I should know about. So I read this document and then I looked at, okay, in my Visual Studio code, IDE, all right, well, this document here says that we did this particular action or this particular thing was changed. I see it in the code. Okay, so it is changed. This is how it's working. Well, why was it changed that way? What was I doing incorrectly or less optimally? All of those questions I was trying to answer. And then identifying, well, hold on a second. Is there any inconsistencies? Is there something, do I agree with all of the changes that are made? Is this aligning with the direction that I'm hoping? And there was one thing which we were able to find. Let's see, was it 001? Yep. All right, and I noted it, and so me and Claude were having a conversation back and forth. So I noted it, right? Oh, and I was talking about it in the last video. Okay, so right here is that it is constantly re-embedding documents into our vector database. It's overwriting the documents, which is good, which means that it's idempotent. But if you're constantly just or overwriting that exact same document, that still means that you need to go and perform the vectorization process. And so I said, well, what we should do is check to see, all right, well, based off of the hash of the document, is it in our vector database? If so, then we don't need to put it back in there, right? So that was the thing that we did yesterday. And now I created another document. So now we're going to be on, this was step one. Now we're going to be going to step two, which is this one right here. So this one is observability and AI evaluation. So I had it create a document which was outlining, before I even created the implementation plan, which we're going to be going through here. So before I even started writing this, I had Claude go, and I said, oh, this is saying an error. This was troubleshooting that we also did yesterday. Okay. Okay, create one more document in the concepts folder, which is going to be it's this one. This document is to teach me the concepts which I will need to know to write and architect the next design document implementation. I think that the next implementation should probably be about observability. I want to be able to get a role at Microsoft as an AI engineer, so I will need deep knowledge and understanding of how to judge, analyze, evaluate, and secure our project or a system. So it created this document for me. And today in the morning, I was going through it. I read the entire thing. I was taking a whole bunch of notes, and then I said, okay, great. Now that I've read this, I can come here and start writing this design doc, and then we can go through and do the AI. We can do the AI follow through and have it actually implement this number two. And there's going to be a slight caveat that maybe we don't implement uh, design doc 2, which is the observability. And the reason is because when I was reading through this document, I was like, well, hold on a second. We're going to be doing a lot of metrics, or we're going to be measuring a lot of metrics, which we haven't fully implemented yet. And we have maybe like one mock, or not really mock, but like fake item. An example. Okay. That might be easier. So if we are trying to do a test to see what documents come up for the vector database, our vector database only has 2 documents in it, and it is very much just us putting random things in there. And let me show you exactly what I am talking about. So our ingestion here, C documents here. So we create 2 documents, and now documents have 2 parts. They have page content and metadata. Okay, so we don't really care too much about metadata right now. That's just where the what document is it coming from and the category. But okay, here's the actual like text or chunk. Employees are permitted to use local scripting tools, blah, 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 right? And then say building, designing, or testing explosive devices or physical hazards on site is strictly prohibited and results in immediate termination, right? Okay, so this is kind of our company policy, but it's just simulated data. That's the word that I was trying to say, just simulated. Now, so we only have 2 things here. And notice that this RAG system is only for one single retrieval operation. So this is just policy checking. There's going to be another one which is trying to actually inject that data into our system. Or sorry, there's going to be another retrieval operation which will need to be trying to provide more context and useful information to the AI agent, not to block based off of if the user has violated policy, but to give the LLM more context to provide a better answer to suit the user's input. So we're going to be using our vector database in different ways, and we haven't really structured that yet. So okay, do we create a test for observability first, or do we make this, like, get the architecture correct to have multiple different calls to the database? That's just one example. The other one is we don't have tool use yet. We also don't have memory yet, but we're going to. So should we go and implement tool use first in our project and then later implement observability? And that was one of the questions that I have here in this document. So we'll go through that, but first let's kind of talk about what it was saying for the concepts. So the concepts are, it was breaking down observability within AI systems. So you're going to have your traditional ones, which are, okay, so I guess the first thing that it did was went and outlined the differences between logs, metrics, and traces. So logs are just simply putting out information that this event happened at this time, and this is the data which It happened at this time. This is what was done, right? So it happened at this time. It was a request to this endpoint, and there was two chunks, and it took this time, right? So it's just an event. It's a singular event. Okay, and telemetry middleware writes structured logs. Okay, great. Now, telemetry middleware is within our C sharp, and that's another interesting thing which we are going to be able to deal with today. And that is that, okay, well, we have a distributed system. Ah, how do you actually go and do a trace between all of the different endpoints, and how do you collect that information? How do you so that's one of the first interesting things, and that's with the traditional data collection. Then the other interesting thing about this is, okay, well, now we have all of these other uh, aspects which are specific to an AI system. How do we collect traditional AI data? So that's going to be like token usage. And it's traditional because it's just like standard deterministic, or it's just like a number, you know? And then, okay, well, now how do we judge an AI model? Now that's very different than just collecting data. Now we need to have rubrics and all of that. So, okay, logs, just events. This happened at this time and this is what occurred. Okay, great. Next one is metrics. Now, metrics is taking those events and compiling them together and saying, okay, well, there was like this endpoint was hit this many times. So we can aggregate over time. And in specific, we are looking, here it is, red, rate, errors, durations. So taking the individual events and trying to be able to aggregate them into some kind of useful information. So request rate, error rate, that our P95 latency, and now tokens per request. Now, so that's an AI specific telemetry information, but it's part of the traditional kind of like workflow that we can easily measure and get. All right, the next one is traces. So we have traces and spans. All right, so trace is the entire process from the user sending the request and all of the different stages which it goes through. Now, what is a stage? That's a span, right? So, okay, this trace, it's for this user's request. Now, within this trace, it's going to go to the gateway. Now, this is our .NET server, okay? And it says that it took 812 milliseconds. So, okay, great. Now, within that, where did all of that time go? That's a long time. What's happening? Okay, well, let's go into the second span. So the second component, which is our LangChain service. And our LangChain service took 795. Oh my goodness, that's so long. Well, let's go into our LangChain service and see what spans took up the most time. Well, one span was this vector store find similar. Okay, well, that took 60 milliseconds. That's fine. One span was our prompt renderer. That took 1 millisecond, so that's fine. Another span was our Olama invoke. Ah, here it is, 700 milliseconds, right? Which makes sense because that's the call to the LLM. That's going to be the biggest thing that we expect to take the most time. So a trace is going through the whole tree. A span is one timed operation with attributes. Spans are nested via their parents. Okay. So, yeah, it answers the question of like, where did the slow, within the slow request, where did that time go? Now, the question that I was having, and we can see the remnants of it right here, But the question that I was having when I was reading it up here was, okay, well, how do you track across all of these different systems? Because it's not just within my .NET, right? This is .NET right here. This is LangChain. It's in a completely different environment. One is in container A, the other one is in container D. So how do you trace that? There's a cool answer. Let's look at it. Okay, so your request crosses two processes, C# to Python. Ooh, here we go. So the magic that stitches spans from different processes into one trace is called context propagation. So the gateway starts a trace, okay, and a span ID. So we have a trace ID and a span ID. When YARP forwards the request, it injects a header, and it's the W3C standard. So it's going to have this header. Now, what are headers, right? They're key value pairs. So here's the key, which is trace parent. And now here's the value right there. Okay. Now notice this is 0, that's 1, and we have our trace ID and our parent span ID. Okay, fine. So it's just taking our HTTP request that we're getting and saying, okay, well, I'm going to put an extra item in the header. Okay, that's fine. Now, what do we do after that? Now, YARP goes and sends it off to our Flask server. Now, our Flask, that's the normal operation. It's just taking it from our .NET server and putting it over to our LangChain service. Okay, nothing strange about that. Flask middleware on the Python side extracts the header and continues the same trace. So we're sending an HTTP request, but now with an extra item in the header. And now when Flask gets that, it's going to take that header and say, okay, well now I'm going to continue that trace right here. So it's not going to overwrite it. It's going to continue it. So both services export their spans independently and asynchronously to a collector. So now we're going to need a collector. We'll meet this new character soon. It's OpenTelemetry. But right now, all we need to know is that they're going to export all of this data out somewhere, and something is going to be collecting it. Okay. And it's going to reassemble it. And now, okay, the header is the entire trick, right? So now here is OpenTelemetry. It is vendor neutral and has a whole bunch of like APIs, SDKs, software development kit, wire protocols, and then this one is OpenTelemetry something protocol. I don't know. For generating and exporting all three of these pillars. So good news, our .NET and our Python both have support for OpenTelemetry. So we are able to use the this like OpenTelemetry instrumentation Flask, and then we will be able to have, okay, our OpenTelemetry SDK from our gateway and our OpenTelemetry from our LangChain go to the collector. Now the collector, now we know who it is. It's this OpenTelemetry. And it's going to be sending it to this Jagger right here. Now I don't know who Jagger is yet. That's something that we're going to have to figure out, but it's something to do with aggregating the data, okay? Now, the other thing that this collector does is sends it to our metrics backend, and that's going to be Prometheus. Now, I've heard of this Mr. Prometheus many times, but I've never had the opportunity to actually interact with Prometheus or Grafana. Now, both of those I feel like are very important to be able to develop as a like professional software engineer. So I'm excited about today because it means that we finally get to meet these two characters that I have been wanting to meet for a very long time. So whenever I'm developing projects, I'm oops, whenever I'm developing projects, I'm always going online trying to find new technologies and things that I think are important. And okay, well, how do I develop as a professional software engineer? And you see these different technologies and frameworks, and you're like, wow, I should go and like look into this, and or I want to try implementing it. I want to see how this works. I want to see how that works. And but you just don't have the opportunity at the time, or you're working on a project, maybe I was about to say a project, but sometimes it's multiple projects at the same time. But you can't really fit that thing that you're trying to do into your current project, and so it kind of gets put. You're like, I'll put it on the stack or the queue. I don't know if it's a. I guess it would be a queue, um, because or maybe a stack. Because then you're gonna say, oh, the one that I most recently remembered. I don't know. If it's a queue, that's a better data structure because then you're going to be just be taking off the ones that you've wanted to do for a really long time. This is not a leak code video. Never mind. I don't want to get into that. But but um yeah, so Prometheus and Grafana were something that I've wanted to look into for a long time. Another example that I recently came across was I was talking with some people at work, and they were mentioning, oh, you should look into N8N. It's like this with like workflow software, and it looks really cool, but I don't really have an opportunity to utilize it right now. So I'm like, okay, well, eventually I want to get to it, but that'll be a future thing. See, so that's what I mean. Anyways, I am all that to say I'm excited. I am excited to meet these two characters that I have been so uh, wanting to meet. All right, so the collector is a personified mail sorting. So means that it's coming in and grabbing all of the event or the I don't know if I can call them events or they're just emitted, right? Sent over by our different services. So, okay, great. Without touching. All right, so yeah, our telemetry middleware is going to start it off because that's where we are. Um, that's where we're actually getting the request is the .NET server. That's where everything starts, and then we'll just be handing it off. Okay, so LLM specific observability. Now, these are the things. So generic traces are just going to give us very like, oh, okay, well this took 700 milliseconds, right? Well, we don't really know what's going on there, or was it a good response, or like how much, uh, what what was the user asking? In any of this information, we don't have that knowledge to us. So okay, we need to come here and say, all right, well, now let's actually try to look at what data we can collect based off of the LLM. So these are going to be the traditional data points. So full prompt, that's just saying like what did the user say? Or what did it say? What did the response say back? So we can just collect that. That's just a string. Okay, that makes sense. Receive chunks and scores. So was a bad answer or was a bad answer a retrieval failure or a generation failure? Okay, so actually this one is going to be that's not a traditional one because we need to determine that, and determining that is going to be a little bit more difficult, right? Because this is just a capture. You capture the string. This one is going to be, well, what is a bad answer? What does that mean? What does it mean to have a bad answer? Well, we need a judge. Okay. And then we want to say, well, is it a retrieval failure or a generation failure? So this is if we get the chunks incorrectly. So this isn't actually measuring if the answer is bad. This is saying if it got the wrong chunks. which actually now that I'm thinking about it is a traditional one because it's deterministic, right? We'll think about that one for a second. All right, so model parameters. Okay, so this one is just collecting. Okay, well, we're using Llama 3.1 and we put the temperature as 0.01, something like that, right? Just like what we put the temperature, what model we used, etc. And the reason why we want to do that is because then we're going to be able to reproduce it. Say, all right, here we are. So we used this model, we put this temperature, and we also know the full prompt. So that means just put those exact same things into the system again, and you're going to get the exact same answer back because LLMs are deterministic. Okay. So token counts, we can just grab that because Olama gives it to us. So context window pressure, that's an interesting thing. I haven't looked into it. I should probably make a note to look into that because that sounds pretty important. Um, hmm, okay. Where would I note that? hmm Concepts document. This one. Okay. Mm, I don't want to lose it because then I'll forget about it. Um, okay. Anyways, I'll try to remember it. I'll try to. So next thing is latency split. So this is not sure. So linkage jumping from Grafana spike to the exact ugly prompt. Not sure really what those two are. Because again, I read this entire document today. This was first time that I've really had an opportunity to get familiar with kind of the idea of observability. Now, as you can see, this is something which I have been for a while very concerned about because, as I stated in the video, like this video, my goal is to develop as a professional software engineer. And I have work experience. My title is technically software engineer, but I do almost 100% embedded systems. So there's nothing with observability, there's nothing with large scale infrastructure. All of this, it doesn't like I cannot have an opportunity to be exposed to these kinds of concepts at work. And so I'm trying to force myself to be exposed to them through personal projects. And that's literally one of the reasons why I'm doing so many personal projects is because I'm trying to force myself to be able to have experience with these so I can understand these concepts. And when I'm going through my ideas of okay, well, what projects do I want to build? Uh, a lot of times, the biggest question that I have and what I weight the highest is okay, what skills do I think that I am the weakest on that are the most important for a professional software engineer? And then I say, all right, well, I think it is X. And maybe I should say X1 and X2. And I create all of these different things that I feel that I'm really weak on. And then I say, okay, well, what project would be able to knock out a ton of these different things that I'm weak on? And then I just do that project. So that's kind of the way that I like to structure my projects. Now, the disadvantage to that actually is that if you do it that way, your projects are very much theoretical learning kind of projects, and they are not, wow, this is so impressive. Wow, this is so useful, right? And so you get into the situation where, well, what can you actually showcase? And it feels like, not much. And that is now like, that is definitely starting to become a concern to me. And something that I might start pivoting in the future is saying, well, okay, well, now maybe it's time to actually do some useful projects. Um, and yeah, so yeah, that's the way that I'm addressing a lot of my things that I've tried to identify within myself and how I go about dealing with my projects. The other thing that I like to do is literally just ask people. So I'll go and talk to my friends who are working at the exact companies that I'm trying to get into and just ask them, like, hey, what do you think is a useful skill? What do you think is important? And then they'll tell me a long list of things that they find as important concepts to know, and then I go and learn those. Or then that's part of my I said skill A or whatever, blah 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 blah, and then I look for what project I'm doing. Okay, well then that's part of that list is okay. Well, this person told me this skill. This person told me this skill, and then I say, okay, well, what projects would be able to integrate a lot of those things in there, so I can get an opportunity to be exposed to that concept which was told to me to be important. Okay, and so again, all that to say observability has been something which has been a very high point in my own head about, oh, I really need to do this because I've seen through people that, okay, what is your job as a software engineer? And I was looking, and what they were doing was a ton of like tracing requests, finding out where the latency was, trying to figure out why something went down so that they could get it back up. And there's this very annoying sound. Womp, 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 womp. I don't know if you, it's the Amazon on call, like, alert thing goes off, whatever, 4 a.m. in the morning. And you, womp, 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 womp. Time to go look at the logs. And then a couple hours later, womp 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 womp. I time to wake up again. Um, I think both me and her hate that noise now. That's like ingrained within us. Is that that womp 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 noise? The Amazon pager is just like on a deep psychological level now ingrained in both of us. um, Even though I've never been at Amazon, um, obviously but anyways, where was I? User feedback. Okay, so this is just like if they gave us a thumbs up or thumbs down. What I was thinking, what I was thinking is actually this might be another interesting thing to judge. Now, we're going to get into how to judge a good versus a bad answer pretty soon. But what I'm thinking is okay, well, what we might be able to do is have the user let's say that I ask Gemini a question. And I say, "Okay, what is this?" Right? And then I say, well, I don't quite understand. And then it gives me an answer. And then I say, well, I don't quite understand. Ba 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 ba. The fact that I said I don't quite understand indicates that the response was suboptimal. Now, what I'm thinking is that the LLM can take a response and try to judge how good the previous response was. And now notice, if the user says, no, that's not what I mean, okay, well, which one is more strong? So, like a higher negative number. No, that's not what I mean. Or, um, I don't quite understand this still. Right? So now there's also gradation. It's not only, oh, the user didn't like it or the user did like it, it's how strong. Or if the user says, oh, thank you, now I understand what you're talking about. That's a strong positive. Okay. And an example of this could be I was talking with Gemini a little while ago, maybe a couple weeks ago, and I asked it a question, and there was no reason for it to behave in this way, except it was saying, "Oh, I can't help you with that request." What? I'm asking a question. I forget what it was. I think it was I was investigating what YARP was doing. It's like, what do you mean? So I said, what do you mean? I'm just asking about how YARP is handling an HTTP request. Why is this against your policy? And he said, I can't help with that. So that's an example of a user sending a message like, okay, this was not in conformance with what you're supposed to be doing. So now we might be able to use a secondary judge LLM to be able to determine, okay, how bad or how good, how strong, positive or negative, was the previous message. That was an idea that I had, and I was like, oh, I wonder if this would work. Now, what's probably going to happen, because this is always what happens, is I think that I'm being so clever. I'm so intelligent. I created this new method, and then I find out it's just a standard method that everyone already uses. It's like, darn. Okay, I thought I was being clever. But anyway, so we'll see if it's a standard method, but it's something that I thought of. I was, I actually thought about it maybe like a week ago or something. I can't, time doesn't matter anymore. I can't keep track of time because I go 7 days a week. I do my full-time job, and then as you guys know, after I do my full-time job, I then come back here, and then I immediately start doing a YouTube video or studying. So I either do one of those two. I do a YouTube video developing engineering projects, or I study for engineering projects. So it's like, and then over the weekends, here we are. It's a Sunday, and my morning was looking at this document, understanding it, and now I'm making this video. My Saturday was, as you can see by the previous video in this series, it was doing that. It was going through this. Well, this is the design document, but we were going through this, and then it created this. Yeah, and doing the code review for it and merging it. That was my Saturday, so time doesn't really have any meaning anymore. Okay, so what was I saying? Right. A little while ago, I was thinking about this, but we were not on observability anywhere near the case that we could implement observability because we were still trying to work with all of the Docker components, getting the networking set up correctly, getting all of that. But I was looking at different technologies and frameworks, and then I heard about this LLM Judge, and then I was hearing other things, and then I was able to be like, hey, hold on a second, what if we put these two things together? All right, let's continue. We have just keep talking. Okay, so okay. I just said that I keep on talking, and then I'm gonna talk some more. But that comment of I just keep on talking kind of inspired something within me. I got a comment, like a YouTube comment, saying, I forget what the exact wording was, but it was essentially saying that I talk too much. And I was a little bit confused by that because I was saying, well, yeah, that's kind of what you do in a YouTube video is you talk. And they weren't meaning like, oh, you don't do enough development. That's not what they were meaning. It was just like, I think what they were trying to say, this was a very long time ago. It's like, this is like a year ago. But I still remember that comment because I was like, what? That was ridiculous. It was, I think what they were implying was that my videos are really long and I just keep on talking. I think that's what they were meaning. And it's like, well, yeah, I mean, you're the one who clicked on the 2 hour long video, and You knew it was 2 hours when you clicked on it, right? But, okay. Um, all right. So, Langfuse. Here is another character that we get to meet. So, what is Langfuse? This is a not really a framework. I'm guessing it's within the LangChain ecosystem, but it is going to be going and actually collecting all of this information. So it's able to understand generation spans, render prompts nicely, aggregate costs, store evaluation scores next to traces. So it helps us with collecting a lot of this information. So another thing that it was talking about, and I spent a little while trying to understand, what does it mean by this? So it's saying that in our implementation plan number 1, so that was yesterday, we created a lot of very good architectural frameworks by which it's going to benefit us significantly today when we want to do the observability. Now, what it's talking about specifically is if I come here into not factory, we want registry. Where'd you go? Orchestration. Yeah, here we are. Okay, so registry and pipelines. These are the two that we care about. So in the past, I was doing it very in a very bad architectural pattern. And what I was doing is just doing a lot of the logic in the API request. And the refactoring that was done yesterday, one of the really cool things that I said in the video was, oh, I really liked how they went and restructured and used a registry pattern to be able to come here and register all of the different pipelines. So here's the registry, right? And then we just serve that. It's a dictionary. And the pipeline is a class. And one of the classes has an object, which is a function pointer that we're able to invoke. So, oh, that's amazing. That's amazing. And I should also point out that when people say that, oh, you can't learn from AI, I vehemently disagree with that, because the position that I'm in right now, I am a single developer. I am the only firmware, embedded systems, and software engineer all in one. So I have three title. My official title is software engineer, but I have three like roles, I should say. And I'm in the hardware department. I am the only person who does these three roles. Everyone else is purely electrical. So I have no one to learn from. And also, this is my first job, straight out of school. So I've never had anyone that I could learn from and grow from. So how would I have ever even known about this thing called a registry pattern? Pulled it out of my head, right? That doesn't make much sense. But I used AI, and the important thing is I didn't just accept that, oh, okay, yeah, this is the way that it did it. Looks good to me. All right, merge. There we go. No, I had it do it, and then I investigated everything to say, okay, well, what's going on? Why did it do it this way? Why is that better? What was I doing incorrectly? And next time, how can I know that, hold on a second, I should put this technique that I remember seeing from my previous project, I should put it in here. So I absolutely think that AI can supercharge your learning and growth as an engineer, because otherwise, and that's one of the things that I'm very like trying to find the right word. Dissatisfied. I don't want to say that too, but dissatisfied with the current position that I'm at is just how do I grow? I don't have anyone that I can learn from. I'm spending so much time and energy at work, but I'm constantly feeling like I'm just doing personal projects because I'm not having any kind of feedback to say, "Oh, well actually this way of doing things is wrong." Now that was but like 4 months uh once again, time has no meaning anymore. But recently, within the past year, I can't remember, 4 months, 7 months, 8 months, something like that, I got put onto a team, and this was the first time that I have ever been on a team. And it was also, I was put into a team with the software department. I cannot describe how much I've grown within those couple months that I've been there. I think it's been around 6 months, something like that. But it wasn't like 6 months dedicated. It was 6 months, but then I was also constantly pulled off to embedded system stuff. So it was like I was part time on the team. I learned more in those 6 months, in the past 6 months, than I have in the past 3 years. I really, again, I don't know if I should say this, but I really feel like I'm completely wasting my time. And that's something that's been really weighing on me recently is like, okay, I'm just completely wasting my time. I'm not growing. And I think it's, I mean, you watch my video, anyways, just like, what was I gonna say? Yeah, like, when you watch my videos, I think it's pretty clear that I really, really want to develop and grow as an engineer. But I just feel like, okay, how do I get those opportunities? And now I have this opportunity that I just mentioned, but it's going away in like a week. So I was told by my manager, nope, we're not going to be doing this anymore. Um, you need to close out the project. Okay. So now I'm going back to embedded systems, and I feel like I don't know. But okay. So yeah. Um what's really nice about this is that because we're using this pattern, we're going to be able to um we're going to be able to have all of our pipelines within this registry, and then we just invoke it using a standardized invocation. So we're doing this like, so we're going to do a get chat, whatever it is, like get pipeline, and then it returns back a pipeline, and then we can do the object that we get back dot handler, and then we pass into the handler an extra parameter here, which is a callback function. So that's kind of the direction that we're headed. And it's nicer because we don't need to change the logic in all of these dispersed uh, function or dispersed locations. So hold on, I need to take a couple seconds of breath. Like a lot of times when I'm talking, um, you don't get you don't get a lot of oxygen, and so I'll be like just like I can tell. Oh, hold on. There we go. Yeah, so I was feeling a little bit lightheaded there. I was like, oh, hold on. I need to take a little bit of a break. Okay. So, privacy note. Now, this was another thing that was kind of interesting. So data governance. Now, because we are having our system all local, we don't need to worry about that. Asterisk. I'm gonna talk about that in a second. But the problem is that prompts can contain PII, so this is personally identifiable information. And so um, the problem is that if we're collecting the prompts, it can violate data governance laws or best practices or whatever your company is saying that they do want to adhere to. Um, so the so it says in industry it's a knob, sampling, redaction, and retention. So okay, this is a point that I need to investigate further. So there was this one, which is like context window pressure, and this one, oh my goodness, we have not gotten very far. We went from here to here in like 30. Maybe I do talk too much. See, maybe that comment was right. But all right, so why might I want to implement this anyways? Is because obviously, as is stated with this project, the goal is to be able to signal and put as my portfolio to be able to get a job as a software engineer. To be able to, now specifically, as I've said so many times in this series, I'm targeting Microsoft. So getting a job as a software engineer at Microsoft, if I'm able to say, hey, I considered PII, this is what I did in my project, I think that that's a very good point. So that's another thing that I do need to consider and integrate into my project. All right, so now judging. Now this is how we're able to actually get the question answered of what is a bad answer and what is a good answer. So we're going to have golden data sets. All right. So a golden data set is a curated set of inputs with known good expectations. So for our reg, we want to say, all right, for this question, we're expecting these chunks to come back. Maybe if an example is if the user is talking about good weather, maybe the retriever should go and get articles about Florida or California, that kind of thing. So that's how we do this to see if the retriever is doing a good job. And if the retriever's not doing a good job, maybe we need to make changes to our chunk size to get a better accuracy. Or we need to do our overlay bigger or smaller, whatever it is. Okay, so start small, like 30 questions, and this will give us a good harness, and then we'll be able to grow it. We'll be able to grow it naturally. And later on in the document, it talks about kind of it talks about a flywheel to be able to take our failures, grow from that, make the system better, and then add those documents as more test cases that we can put into our golden set. So next one is the retrieval metrics. So based off of the retrieval which we get, we're going to want to know, okay, what was the top K hits? So for what fraction of questions does the correct chunk appear in the top K? So this is really simple. Like, let's take that example of Florida. Maybe that's not a good one because both Florida and California would be expected. But okay, let's say that the user wants to do something illegal, right? And then our policy specifically outlines that that type of action is against company policy. We expect that the user message is going to invoke this retrieved chunk. Now the question is, okay, um, how many message received chunk pairs did we get successful? Was it within, was the expected message within the item that we get back? And what is the item we get back? It's a list of k number of chunks, and is the expected chunk within the set that we got back? Yes or no? Next one is the mean reciprocal rank. So now this one is dealing with the order. So now I say, okay, well, I have expected this chunk back. It is within our response back. Is it third place? Is it the eighth item given to us? Or is it the first? And first is the best. So that's why with this one here, it's 1 over the rank. So 1 divided by 1, that is equal to 1. If it's third, it's 1 divided by 3. That's 0.33333333. Okay. So, precision and recall when multiple chunks are relevant. Now, this inspires something deep within me. Um, so I took, when I was doing my bachelor's, my degree is in electrical engineering, but I took a lot. I really liked the machine learning AI classes. Now, this is before ChatGPT. So when we were talking about AI and machine learning, what that meant was developing a neural network using back propagation to be able to minimize your loss function, um, being able to train things by hand. That's what AI meant. Um, but I remember in my class, precision and recall, and that, yeah, so I remember that, and that was a very difficult class. Oh my goodness. That was my favorite class that I took at Oregon State University. It was so good. It was a senior level. I had a lot of actually good classes. But that class, it was a 400 level machine learning course, and it every single day you go to, or not every single, it was whatever, Monday, Wednesday, or Tuesday, third, whatever it was. But each time you would go to class, you were just inundated with 2 or 3 hours of just the most dense mathematics, statistics, vector calculus, all of just like, you got out of the class, you're like, I have no idea what happened, and then you have to go and study it for the rest of the time. But it there was so much to learn, and it was just drinking out of a fire hose, but it I learned so much in that class. All right, so now we're gonna, because of these, we're gonna have thresholds. Now currently it's disabled, but we'll be able to adjust that threshold and start gating things. And now this is another aspect to our CI pipeline. So we're going to be able to now make sure that we are doing tests on our system itself for the AI to know that, okay, well, it's not, it's still giving us expected results back, the LLM itself. All right, so generation metrics. This is the one where we use the LLM as a judge. So what it's saying here is that we are going to take the LLM, its output, and we're going to feed it to another LLM. Okay? And then what we're going to do is we are going to give it a metric or a rubric by which it needs to judge the prompt. So the LLM, the response, the chat LLM is going to give back a response, and now we're going to use a secondary LLM to judge this response. But this judge LLM needs a metric by which to evaluate the response. So we need to provide it that. So we need to give it a metric, and it's talking about this like reg specific rubric is regus, and we're going to have faithfulness, which is every claim in the answer is supported by the retrieved context. So this is against hallucination. So if the AI makes a claim, is it substantiated? That's faithfulness. Answer relevance is, did the LLM answer actually match, like answer what the user is asking? Context, precision recall, was the retrieved context the right context? Okay. Now, before I get too far off, hold on a second. Let me come here so I can remember my place. I do want to make a note about this. So I'm going to go into the design document. And then I can say LLM is judge and say another interesting idea. And we're going to have to go through this document as well. This is the document that we're actually going to be generating the AI to do what we want it to do, which is the metrics and observability implementation. So another interesting idea which I had was for user feedback. It is mentioned in the let me copy and paste that name. Concepts documentation, this one. Copy path, where is just copying? Okay. Here, that we can use if the user gives us a thumbs up or thumbs down to determine if the LLM's answer was good or not. An idea which I had was we could also use the user's response message back to the LLM to determine the quality of the previous message. Okay, so an example of this would be if the user got response A and then they followed up by saying, but I still don't quite understand, this indicates that response A was not optimal. So the follow optimal. So the follow-up message, the follow-up can indicate information about the previous message. If we use an LLM judge to look at users' follow-up response responses, follow-up messages, we can have it judge the previous LLM response based on degree of positive or negative. Okay. If the user says that's not what I mean at all, this is a much stronger negative indicator than just saying, but I still don't understand. So the LLM judge would rate the stronger negative response with a larger negative number. Likewise, if the user says, thank you, I got it now, this would be a positive indicator of the previous message. Okay, so I just wanted to make sure that I did put that in there so that we don't forget about that. So, critical caveats. The judge itself is a model, so it is going to be biased towards like very verbose answers, favors its own phrasing, it's inconsistent, it needs calibration, all of those. So now we need to ground it, or we need to give it a human approximation of judgment, and that's going to be with I'm going to be providing examples. Okay, so now regression, gating, this is what we talked about already. We put the answers into the CI pipeline, and we don't let things pass if it's too low. And this is the flywheel where we're talking about being able to take failing responses and manually figuring out why they failed, what's going on, and then we put that back into our data set as a golden one that we manually did. Okay, so now it's talking about security, and it's saying that this one should actually be its own implementation plan. It was talking about some of the things that I might be interested in the future, so like prompt injection, output policy, resource abuse, all of this kind of stuff. So, okay, I agree, like we can hold off on that. And then gave a scoping plan, and then we're done. So now the next thing is we need to fill this out and then start having Claude go and start working on it. Okay, so sip of coffee, and then we'll get into this document. So, I actually might say I'm going to do relative path this time. Where'd you go? Copy relative path. Okay. So, this document is an outline of here, which was made to overview the concepts and ideas which will be needed to be understood during implementation. Read that document to get a better understanding of this implementation plan. Okay, so we're going to get that, and now say, after this implementation, the system should be fully wired up in a suitable and well-architectured way to capture, log, and display all telemetry data coming from the system. The telemetry data should be both the standard traditional data, such as latency, error rate, request rate, and traditional data specific to AI systems, so like token per resource, etc. In addition to the traditional metrics and telemetry, our system will also need to produce, collect, report, display, and process AI information, so LLM as judge, vector database, retrieval, judging, etc. All of this information will need to be collected and be able to be viewable to the users. Another thing that I'm now thinking about is that we have not yet added tools and memory into the system. So do you remember at the very beginning of this video, I said we might not even implement this one yet, right now, today. And the reason is because of this line right here. So we haven't implemented tools and memory into the system yet. This is going to be something that we want to do, that we also want to have observability for. Therefore, in this implementation plan, we will need to do it in such a way that allows for easy addition and integration of tools and memory. Maybe this means adding fake stubs, or it means holding off entirely on this implementation plan and working on the tools and memory plan first, then returning to this plan. So, okay. Now for retrieval. This can be done within the CI testing regularly because it will be cheap. We will be able to deterministically test the quality of retrieval of the documents from the vector database. With the retrieval, another thing that we will need to be taken into consideration is the architecture. Or with the architecture is that I am planning to have different tables for my vector databases. One will be for like acceptable AI usage. This will be used to block potentially harmful user requests. Another table will be a group of documents that might be useful to supplement the user's message to give a more helpful answer. So as of right now, we only have one vector database table, but we need to keep in mind that we're going to be expanding this out to have more. So we need to keep that the architecture of how we're dealing with the vector database scalable to allow for more in the future. Okay, so LLM as judge. This will be the LLM to judge the responses back. So because the LLM is itself a model, I will need to provide human examples as to what kind of responses will be expected and hoped for as responses. When creating this system, give me a stub document and indicate where you want me to fill in human information. I think that we will also need a rubric, or maybe what I just described is the rubric itself. I also know that there is a standard of Regis, which we will want to follow and implement in this evaluation system. So now, Later it said that Regis should be like out of scope, so that's why I'm a little bit confused. So it said, although I'm confused about why Regis would be out of it if it's part of the retrieval metrics, which is in scope. Um, okay, is this anything important? Okay, so when implementing this, it will need to be considered carefully from an architectural point of view because as of now, our system has a placeholder friendly prompt assistant. But in the future, we will be changing this so that we can have more nuanced and better responses. We might also have different type of message responses based on parameters. I should say message uh, prompts based on parameters. So we will need to have our system be able to plan for this. Okay. So errors to fix before starting our implementation. These are the errors that we observed last time in the last video. So when I log on to OpenWebUI, I should only and always connect to my .NET server. So it was connecting to my LangChain server, which is wrong. I should only be able to reach my LangChain test endpoint with a curl command, not the Olama one. Or sorry, not the OpenWebUI. Now that I'm thinking, or now I am thinking that I need to look into the architecture on this because is it that we are automatically reporting all of our endpoints which we registered to Open Web UI? Because if that's the case, then this becomes more difficult to change. So, but it still should be the case that we are automatically connecting to the .NET endpoints. Okay. And then I also said when I first open up my Open Web UI on my browser, I get spammed with messages telling me that I'm connected. Okay. And we saw that yesterday. It's a connected, like that. And it was like, whoa, okay. So in scope, I like the outline which which was given for this plan. So we're going to have open telemetry tracing. So gateway, route, span, and then transparent propagation, Flask registry spans, go to collector, local trace for backend. So, okay, great. The metrics are the red that we saw. This one was this delay, error, and okay, let's look at that. What was red again? Where did it go? Somewhere in here. So here. Okay. Here. Rate, errors, duration. Okay, duration. Rate, errors, duration. Token latency, per pipeline ID. And then we have Prometheus plus one Grafana dashboard, or plus, yeah, so Grafana and then one Grafana dashboard. All right, so LLM layer captures. So prompt chunk tokens per invocation at the registry boundary. At the registry boundary, so that's another thing. So we need to make sure that we do all of these different things at like the logging, and that's something that I should explicitly say because it was talking about here. Wherever it went. So okay, well obviously I can't. So it was talking about the architecture with the registry. Open telemetry, yeah. Anyways, whatever. The thing that I was going to mention is like it was talking about that um, because of the way that it's registered, um, we need to make sure that we um, invoke it based off of the. I talked about, okay, so I come here and I think I put it in here. So let me just refresh this one then. So, because I was going, when I was reading through this document here, I was also taking anything that I didn't understand and putting it directly into Gemini and asking it, well, can you show me an example of what this would look like? So one of the things is, I think it was this one up here. I said, okay, so the architecture insight for your system, let's just control F that. So this is what I am looking for, right? Okay, here. So this is what I'm wanting. So every pipeline is invoked through the registry with a uniform signature, one wrapper at the dispatch site. And then it says, when you write stage 1, say explicitly instrumentation attaches at registry boundary. Okay, so vocation at registry boundary. And when I went to Gemini, it was talking about how what we can do is come here, and instead of having this is the bad architecture. Because we're invoking it in this way, we're going to be able to come here and then just have like a callable, but it's, whoops, okay, there we go. But now we pass in 2 parameters, so we just pass a callback function. So I need to where in here be able to indicate that idea. So general feel, this one. Maybe I can say here, vector database retrieval judging. After implementation of the system, should be fully wired up. Okay. For Lang fuse operations, we should make sure to take advantage of the registry pattern we developed in the previous 001 implementation. We should attach metrics. Attach what? Implementation, instrumentation at the registry boundary. Okay, there we go. And so, yeah. Over here, all of those out of scope. So alerting and paging, we're not going to alert if we have a bad system. No streaming, that's fine. Security gateways, we're gonna deal with that later. Checkpoint memory, Ragus the library. And then I put a comment, although I'm confused as to why Ragus is out of scope. So let's commit this and commit wrote 002 metrics observability document. Maybe design document. Design document. Okay. So now I'm going to come in here and now we can say, I have now written the design document for 002. Okay. Please read it over, but make sure to also keep in mind what you wrote within the 018 observability document, because today I read through that document and wrote this 002 to the best of my understanding of the concepts you wrote yesterday, but I still might have not quite fully captured or understood. Make sure to use good. Okay. Let's start our discussion for stage 2. Okay, so there we go. So it's going to start stage 2 in the 002 document. So this was stage 1 right here, and now it's going to start stage 2 down below. Okay, so running the script and doing all of that. So while it's doing this, I'm going to take a couple seconds to breathe again. Thinking. Okay. All right, here we go. So it's now responding. So it's going to go and try to create a outline like an implementation plan. So that's stage two. And stage two also has a section for like a back and forth discussion between me and Claude. Okay. Which file are you editing? Does it say? I'm guessing it's this one, but okay. Thinking. All right, there we go. You captured the architecture well, registry boundary, two-layer model, cheap versus expensive tier. The short version of my entry. So, corrections. It's regus and it's a library, not a standard. The metrics are in scope. We just compute them ourselves. Your hyperfixation instinct is an asset here. Oh, okay. It's pulling from my persona .md here. So I put here like observations about myself, and I said like I realized that I really hyperfixate on details of like I can't just take an abstraction and work with it, which is a big disadvantage because you might say, oh, well, you're understanding the system on a deep level, but you also go very slowly. So I need to like force myself to be able to be more comfortable with abstractions. That's what I was talking about here. So, yeah. Anyways, so more important, I sharpened something from 18 you'd have hit later. So mock mode retrieval metrics test the machinery, not quality, because fake embeddings have no semantics. Real hit K needs live embedding, so evals get 2 tiers. Your OpenWeb UI worry dissolves, which host it dials. Okay, and which models it sees here. Proxies through the gateway are independent. Nothing needs restructuring. And I split the rubric versus calibration set with 2 roles for your human examples, stub files here. Okay, so your ideas. Don't block on tools. Okay, so we'll proceed today. And don't stub them. Instruments. Okay, instruments the seams, and future features inherit spans automatically. 2 vector collections is the right pattern here. There are PG vector, okay. The harness gets collection parameterized. The follow-up message feedback idea is genuinely good and a real production. Darn, see? It's already a technique. Out of scope until memory exists. Darn! Okay. Thought I was being clever. But it imposes exactly one free requirement now, thread ID in the but it imposes exactly one free requirement right now, thread ID in the trace schema. Okay, so the big decision. Langfuse now versus OTelemetry only first. It drives container count, SDK, span granularity. My lean is Langfuse now, reusing your existing Postgres because the evaluation half of 2 needs somewhere to put the stores. Okay. So I'm going to come here and it did a whole bunch of editing, right? Guessing here. Okay. So let's kind of go through what it's saying here. So let's git add here, git commit, Claude's response. Okay. Cool. So we already talked about this. An honest sharpening of, so discussion. Okay. But we need the steps too. Or was steps part of the, hold on, let me go to ClaudeMD. And so this one we're in discussion. Ah, here. This one has okay. Here's the discussion, and then we go to the steps. Okay. I wrote that document, what was it, yesterday or Friday? I can't remember. So, an honest sharpening of what 18 said about retrieval. Okay, your open web UI dissolves once you separate two independent things. You asked, are we automatically reporting all registered here, all registered pipelines to open web UI? Then this will become more difficult to change. So separate them. Which host web UI dials is pure config? Okay, good. The fix from found issue number 3 points the saved connection to this. I'm guessing that's in our Docker Compose after the registry is generated, but that endpoint is served by LangChain and reached through the gateway. So auto reporting all pipelines and only connect through .NET are perfectly compatible. Nothing is different to change. Okay. The toast spam is a symptom of the broken connection URL. So front end retoasts per socket reconnection, while model fetches fail. Expect it to vanish when with the fix. If it doesn't, we treat it separately. Okay, cool, awesome. So that was the thing that I said yesterday. If you remember in yesterday's video, I said, okay, I noticed that there was this problem, which was it was being spammed, blah, 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 blah. And it was, everything was working. It just spammed for about 10 seconds and then it went away. And then everything was working. I was like, I really want to just merge this. And I was just very excited because it was kind of to the point where we finally got a minimal viable product, and I was like, I'm gonna merge it, even though I noticed that there's this one problem. We're gonna deal with it later. I was just too excited, okay? But I said we're gonna get to it later, which later means today. So yeah, so good. We have, I made sure to put that in our documentation for the next one so that we didn't miss that. Rubric versus calibration. You blended two related things here. Okay, so they are separate. The rubric is the scoring criteria handed to the judge inside the prompt. So score of 1 to 5, where 5, every claim is supported. Okay, the human examples serve two distinct roles. A few go into the judge prompt, and a few shot anchors are a separate held out set. Okay, like testing data versus training data. Okay, or not really training data, but example data, I should say. Okay. So if the judge disagrees with your held out scores wildly, the judge isn't trustworthy yet. So yes, I'll deliver stub files with clearly marked Timothy slots. Okay, cool. So now responses to your 3 ideas, don't block them, and it's going to do this. I'm actually very curious. I'm going to leave it, and I'm very curious how it's going to implement this. And so what we're going to do is we're going to have it go through and implement it, right? Just like we did in the last, in 001. We're going to have it implement it. Then it's the code review section of it. So then I'm going to have it create a document, just like I did last time, where it goes through everything that it changed, the concepts behind it, why it changed it, what was wrong with the way I was doing it, why it did it that way, how this is working, how everything. And then I'm going to read through everything there. Then I'm going to look at the code and see what it actually did change and say, oh, now I made that connection. And then we can do the merge request. So this is something that I'm very curious about. Like, what is it actually going to do? What does it mean that, like, with all of these fake stubs and creating the registry with two vectors somewhere. I don't remember where I saw it said something about two vector collections, right? Like it's like oh, vector collections, that just means the vector database tables. Okay. But it was talking about the architecture by which it's going to do it. And so that's why I'm kind of curious, like, okay, I trust you actually. Kind of. Trust but verify, right? So it sounds like a good plan. Um, I'll have it implement it. But then once it's implemented it, now during the code review, that's when I have to go in and actually understand what it did, see if I like that, see if it makes sense, and see if it not only makes sense in our current stage of the project, but the direction which I see the project going. So, okay. So mining follow-up messages is, or as implicit feedback. Okay, this said it was out of scope. Okay. Decisions before stage 3. The operating weight question runs through all of them. So full observability is potentially 6 new containers. Open telemetry, Jagger, Prometheus, Grafana, Langfuse's DB. On top or on one laptop next to a llama, that's real weight. So each decision below is partly how much do you want to run. Okay. So D1, decision 2. Okay. What I'm thinking is that we can, within our build, we can pass in parameters. So let's see. So Langfuse now. Purpose-built UI renders prompts, prompts and generation beautifully, stores evaluation scores next to traces. The flywheel is one tool, okay, on your roadmap already. So cost is 2 extra containers, can likely reuse our existing Postgres instead of a second one. Worth investigating in stage 3, plus 1 SDK in the service. So the OpenTelemetry only first. So prompts tokens as spans attributes in Jagger. 1 mental model, minimum weight cost. Browsing prompts in a generic trace UI is clunky. So yeah, let's go with the Langfuse one, even though it's heavier. But let's have that passed in as a parameter. So I'm gonna say here D1 okay is, let's do the full lang chain or lang fuse now. But let's make observability as a passed in parameter to our build script. Okay. This way we do not need to have those heavy items if we just want to simply run our system. Okay. So D2. All right, trace backend. So all in one. Single container, zero config. Alternate is Grafana tempo. Integrates with Grafana, but more config. Recommend Jagger, low stakes, easy. Swapped later thanks to collector indirection. I don't really know the implications of this decision. But if you say that Jagger is easily swapped out later, and what is the argument against using this Jagger? More config, easily swapped out later, and is the lower stakes, then I guess it does not really matter either way. Do the one which will be easier for me to see what is going on and understand the concepts. After this 002 is fully implemented, I will be going through all of the changes which you made and learning all of the concepts. So pick the one which will be most clear from a conceptual point of view. Okay. That's D2. D3 is going to be what? Golden data sets. Okay, so here, ID question. Okay, lives in LangChain here. Expected IDs are the SHA content hash from plan here. Nice payoff. Are deterministic IDs make evaluation stable. You author 15 to 30 items against the seed policy docs. I deliver the stubs with 3 worked examples. Sounds good to me. Okay, D4. Judge execution. Okay, so live tier only for real scores. The mock response pool you wrote months ago turns out to be exactly the right fixture for this. Same 2-tier logic as A2. A2 is answer to. A2. Oh, I see what it's doing. I thought it was D for decision. Oh, it is, right? C, A, B, D. Oh, whatever. I don't know. I don't know what it's. Okay. So same two-tier logic as A2 applied to the judge. Okay. Yeah, again, sounds good to me. D5. So span granularity inside pipelines. So per graph node spans come nearly free via callback handlers if we choose Langfuse. Yep. Okay, hand rolling. We selected Langfuse, so we should be good. Okay. So okay. Now come here and say, I have now responded. If you think it all looks good, go ahead and implement step 3. Okay, there we go. And finally, we get to take a little bit of a break again. Okay. We're almost there. We are almost there. We are almost to the point where we can start actually developing. And by developing, I mean having Claude go through the plan, which it's making the plan right now. So it's gonna go step 1, 2, 3, 4, all of those steps, and then we'll be able to be like, okay, looks good to me. Do step 1, do step 2, do step 3. Okay. All right. So now it's creating it. Editing. Red. Oops. To open this file. Yeah, go ahead. Okay. I don't know. Maybe it was because it opened from this application that it was trying to. I don't know. I didn't want to press yes immediately because I didn't want to interrupt it with what it was doing here, right? That's why I was like, I don't know if I should. Yeah, okay. All right, well. Okay. All right. Here we go. So I did that. Now it should be, okay, cool. So now what I want to do is I want to do git add, okay, git commit, and then I say created metrics implementation plan. Okay. Now we can push it. And the good thing about that is then we can read this in more formatted way. So let's come here. Is it this one? No, but it'll be one up. Okay. So here we go. Oh, and it did change the implement. implementation. Wait, what was changed about this? 28 minutes ago. Hold on. I'm not too. Hold on. Wrote. Did I change something or did it? I'll need to investigate that later. Because if it. Because one of the things that I'm trying to do with this project as well is obviously understand the concepts within this personal project, be able to develop and understand these important concepts, develop a cool portfolio project. But the other one is learn how to use AI effectively. And so if AI did something which I wasn't expecting, then I need to make sure that, okay, well, what did I do to cause it to do that? Do I need to change my rules? Do I need to change my Claude MD? Did I say something in my prompt? So what was going on? Why did it go and change that? Because I'm not expecting it to go change yesterday's implementation plan when we're here. Okay. So let me come down here. And so here it goes. All these different steps, and created acceptance criteria. Okay, and then discussion. Okay, so implementation plan here is stage closing. Okay, so decision law. It just kind of solidified what we said. Okay. So ordering principle here. Every step leaves this repo runnable and independently verifiable. Okay, so this with no observability flag must behave identical to today after every single step. Okay, so the target topology is this right here. Goes gateway, traces. Here, metrics, okay, going to back and forth between Prometheus, which then gets sent to Grafana, which we can query to be able to get our dashboard, okay. The telemetry collector goes to Jagger, okay, which we're gonna have, and then Langfuse goes into the Langfuse database. Okay, sounds good to me. 2 transport models on display deliberately for the concepts. Okay. Okay, observability infrastructure here. So this is going to be step 1. And let's just say okay, because it's going to take some time while doing it. So what I want to do is say looks good, start implementing step 1. Okay, so now it's going to go do its thing. And then while it's doing its thing, we can come here and kind of read it. Although, can I just get out of here so that we can... oh, or we could have just looked at this. No, okay, whatever. I'm going to close that so that we can kind of... oh, well, we're not going to be able to see it anyways, unless I do it like this. We can come here, move this over here, right? And then I can move this one over here, but now I'm in the way, but I can just move myself. And then everyone will be happy. Okay, so what it's doing right now is, and the way that I do this is I just go through step 1 and then I commit, then go step 2, commit, and I just do that. I just keep doing it because I'm not going to go and I don't really understand what it's doing right now, right? That's the code review section. I'm just going to have it do step 1, step 2, and do all of these steps all the way to the end, whatever that is. Is it 10? Okay, well, it was 10 last time. It's 9 now. Or it was 10 in 001, and now it's 9 in 002. But just do all of the steps. It'll change everything and then create a document, concepts review document, study that document. Now I can go and do a code review, understand everything that it changed, right? So I can't even intelligently look at the changes that it's making right now because I don't know what it's doing. I have no idea. I don't know those concepts yet. That's why I need to go and have that document. Done and logged. Awesome. So what that means is we now come here and we can do get status just to see what it changed, right? So observability, and it changed the Docker Compose. It did this. So it edited the markdown file. Yep, that makes sense. Awesome. And changed the build script. Okay. And now I'm just curious. I'll look. I said that I wasn't gonna look, but I'm not gonna be understanding. And normally what I do is I just say, okay, go to step 2. So observability. Where is observability? Where am I? PWD is LLM monitor. So observability. Okay. And now I have Grafana here, dashboards. Okay. It's just YAML, just configuration files. Okay, I want to check my Docker Compose as well. I just want to see if that has these new containers. So it is modified. We have this observability enabled. Okay, good. I like that. .NET service. I also want to check the Open Web UI. This one. Okay. So we have this one. So we have this Jagger. We have the OpenTelemetry collector container. We're going to have Prometheus. We're going to have Grafana. We're going to have, we already have this one. And then we're going to have those 2 new volumes. Yeah, looks good. So git add and then git commit and say implemented this. Okay. Push that out. Okay. Now I can say step 2. Like that. There we go. And it will do its thing. I can take a sip. All right. While it's doing that, I can go and but we lost it. Here it is. Yeah. So let's see what step 2 is. So step 2 is gateway and C#. How do I want to structure this so that I'm able to easily get in and out of things? So what if I go like this, right? And then I have this one like that, right? So I can click there, and click here. Yeah. Oh, but then I can't click this one. Okay, so now what I need to do is come here. There we go. Now I can just go click. Okay. So, awesome. So it's doing step 2 right now, which is gateway C# implementation, which means packages, this OpenTelemetry. So we're adding those, I'm guessing they're just NuGet packages within our .NET server. Okay, and then this exporter, Prometheus, now program.cs tracing, root span, injection into the proxy hop, YARP forwards via HTTP client, which we're going to learn all about what this is later. No exporter. Okay. Yep, looks good to me. Right, looks good to me. So got that. Come here, get status again, just see, oh, cool, it changed program.cs. Okay, so it's all in my C#.net. Okay. Ah, I did not set it up correctly. This needs to be down lower. And it needs to be like that. And we need to come like that. Can I move you? No. Okay. Now I can click here and okay. So git add git commit and say implemented this one. Okay. Now I don't need to actually push it because we're just gonna keep doing this. So git step 3. Okay. So let's go look at step 3. There we go. Okay. So step 3 is LangChain service, Python tracing. So dependencies. So now we're trying to get the open telemetry for the Python. Okay, that makes sense. Is that all we're doing? Manual spans at the same seams. Okay, so this is the one where we're doing all of the seams. We're going to be are we doing the other stuff, which is like, so this is, it doesn't look like we're doing the other stuff, which was, we have the open telemetry here, which is what we're doing. But then we also, so this is going to be taking that header that's passed in from our .NET controller and going and appending it and carrying on the trend. So that's for the trace through and then back. But is this one also doing the one which adds Lang Smith, I believe it was called, for being able to collect data of the actual like token usages? I'm not seeing anything with that. So let me make sure that I have this copied in my clipboard so that we can easily do our commit. Ah, here's LangFuse. So it wasn't Lang Smith. What's Lang Smith then? I don't know. Step 5. Okay. Here. All right, we are on step 3. Okay. Cool. So once that finishes, then we will just commit that out. Okay, and it finished. So what are we going to do? Git add, git commit, and implemented step 3. Okay. All right. So step 4. There we go. What is step 4? Let's look. So that one is going to be metrics and Grafana dashboard. So here's where we will actually go and get introduced to Grafana. So here we go. This is our, so Prometheus is going to collect the data or get the metrics, and then it's going to send that to Grafana, and Grafana is going to be able to provide that dashboard for us. So here we go. We get to meet that person that we have been so anticipating for a very long time. Okay, so Prometheus and Python request this all labels. Okay. Metrics on Flask app here in mock dashboard. So then we're collecting the red. Okay. Rate, errors, and duration. Okay. Yep. AI row here, retrieval hit, token count, all of that. Okay. So it's fine. All right. So going through and doing all of this. Okay. So let's see if we're able to go through each of the steps, or if we are going to hit our limit. We'll see. We'll see. But then if we hit our limit, it's no problem because it's literally just continuing to do this. So I'm just going to continue to go step by step by step by step and then commit, step like that. And then, so if we hit our limit, I'll have to end the video there. But then just uh, once my limit resets, then I'm just going to keep doing that. Not in the video or not in a video. I'll just do that. And then once we go through all the steps, then what I do is I'm going to say the exact same thing. And I need to make this a skill, but it's going to be this right here. So after okay, so this right here. Write a comprehensive document in the concepts folder outlining everything that you changed, any new architectural patterns, and anything else I need to know or understand, judge, and eventually merge these changes. Okay, so I wish I could just put that. Okay, whatever. So have you finished yet? No, you were still going. Okay. But yeah, I need to make that a skill to be something like, I don't know what I'll call it, but um, summarize and teach changes, maybe, would be the name of that custom skill. Okay. So 18, wow, 18 files edited. Whew, this is a big one. Oh, and it's still going. So survives only in components or comments explaining its removal. Okay. So this with multiple Gunyan workers means, so multiple Gunyan, that's like multi-threaded or like, yeah, multi-threaded. So scrapes. Okay. So this one is step 4. So let's get status. Let's see. So it did all 4 of these. I thought that we had a lot more files changed here. Edited 18 files, created 6 files. No, whatever. Okay. These are the ones that it added. Okay. But then this one, it modified all of those, including contracts because we're talking about the seams. Okay, so git add, git commit -m, and we are going to say implemented number 4. Okay. All right, and now we can say step 5. Okay. And let's go and read what step 5 is. I should just say next step because what if I, okay. To fetch, yeah. Lang fuse, allow for this way. Yeah. Okay, so this is step 5, right? Next time I'm going to say next step because I don't, wait, no, I do want to say step because then I want to make sure that my commits are in sync with it. I also need to think of a way that I don't need to manually do this. Like git add, git, and then, okay. Which deployment do you want inside sure. Yeah. All right, so this one is Langfuse. Ooh, Langfuse. Okay, cool. Yep, which makes sense because that's why I was asking me all of that. Here, data store, known risk, decide with your input during implementation. So V3, oh, that's what we just approved. Yes, recommended. Once this heavy fallback is pinned, okay, single container with, try this first, okay. Lang fuse, lang chain, callback handler. I feel like there's going to be a lot that I need to study. Okay. I'm going to close this. Okay. Whew. Oh my goodness. Oh my goodness. What is this? Okay, so Langfuse web. Ooh, uh-oh. I don't want something to go out to the internet. I want everything local. Hold on. We might need to look into that before we do it. Just because that's kind of what this project is. I want it to be an edge device. Database URL. Oh, it should be to the volume, right? Postgres QL. Oh my goodness. Okay, so Langfuse Redis. Oh my goodness. There's a lot going on. I don't know what's happening here. Or how big all of these things are going to be. Yeah, hopefully it's not too big. Okay. Well, we'll see. And it is still editing happily away. Yeah, this is going to be a lot. Okay. So, get status and see what changed. All of that. Okay. Yeah. So, and this was 5 or 6? Stage 5. Okay. So, get commit here. Minted this one. Okay. All right, there we go. And now might as well push it just because we've done a lot. So just flush it out to the remote. So step 6. All right. Eventually we're going to be running out of tokens. I guess we haven't already. Let's see. So this one is this one. So I'll copy that into my clipboard. LangChain service, human. Okay, so this is creating the stubs that I will need to fill out. So we'll need to get that as well before we merge this in. And then we'll need to test it. Then we'll need, well, first we need to understand it. Then we'll need to fill this out. Then we'll need to test it. Then we'll need to make sure it conforms to the direction that we're hoping, all of that. Then we can merge it. But I feel like this is going to be a very big thing to try to digest and understand. So, okay. including a shared loader. That's step 7 will reuse. Oh, okay. Okay. Yeah, this part is always the most boring. It's literally just stepping through everything and then committing and then stepping through and then committing and then stepping through and then hitting your token limit and then coming back 6 hours later and then stepping through and committing and stepping through. It's like, okay. Okay. Well, time for some coffee and let it do its thing. All right. Looks like it's done. There we go. So implemented step 6. Yep. All right, and now step 7. Okay. There we go. And now let's go look at this one. What's it doing here? This one is retrieval evaluation. Okay, so this one is we're on our reg vector database. We're going to try to find out all of those different metrics like the k-hits and the mean reciprocal, because it was the reciprocal went over the place. Okay. So do this one, and then we only have 2 more. Okay. So we're almost done. Almost. Okay. And then what we can do is we can also do a draft pull request, and then we can really easily see kind of the changes that have been made between everything, or between our main branch, which has been unchanged, and then this one, which is called AI development. So if we do a draft PR, it'll give us the changes really easily. Okay. All right, well, it's still thinking. That's fine. All right, there we go. So come here, status, get add here, get commit, and then what do I want to say? Implemented this. Okay, so this is 7. Now let's go step 8. All right, let's go look at step 8. All right, only 2 more, and then we need to create the document, right? The concepts document, which we will use to study, and then we'll be done for this section. And then we have to do the part, because it's always the 2-part, the study to even know what you're trying to implement, and create this document, which is the design document. That's step 1. And then once you make those changes, then step 2, the code review part, where you need to go and actually understand what is changed. So we need to create the document which does a lecture for what was changed. Okay. So this is almost done. Judge evaluation. So faithfulness scoring, existing, upgraded. Okay. So verification, plumbing, test, green. All right. Stage 5 scaffold. Oh, okay. Stage 5 here. Okay. So, oh, because it's an old, right. So it's been editing it and putting it here. Um, so that's why it edits it at the end of our converse or at the end of each step. But I have not refreshed this page, which is why it just says not gotten to yet. Okay. So, all right. So it's still going along, and well, okay, there we go. Step 8 is done. So git add, git commit, implemented step. Oh, paste. Step 8. Okay. So now do last one. Step 9. Go. And we'll see. Last one. Okay. So this one is going to be this right here. Okay. So hopefully it'll just be really fast. Okay, so thinking. Again, this is always just the most tedious part. I need to find a way to just automate this so that I can walk away and don't need to worry about it. Just I wonder if I could tell it. I don't know if it has access to my terminal. It might, but if it does, I could just say I could tell it to do all steps to push it with the one that I already created, right? Or like that template. So like commit with the message implemented X, where X is the step title. I should be able to do that. I'll do it. I'll try it next time. We'll see if that works. I don't know if it has access to my terminal. Okay. So well, okay, there we go. That looks good. And so it's gonna finish. There we go. Okay, cool. So git add here, git commit this, implemented this here. And now I will do a push to get that all out there. And then we need one more thing. As I said, we need to come up here and get, so this one, and then write a comprehensive document. Yeah. So this one, and we're going to want to say the same thing. So write a comprehensive document in the concepts folder outlining everything that you changed, any new architectural patterns, anything else I need to know and understand about this. Teach me all of the concepts that I might be unfamiliar with, might struggle with. Okay. There we go. So we're going to do this. And then it's going to go and create a new document we'll be able to push that out, and then we should be done for today, or I should say for this video. Obviously, I'm not going to be done for the day. I still have a lot more that I need to study. Um, but I will probably we'll be done with the video is what I mean. Okay, so it's going. It's happily writing, doing its thing. And now the other thing is I can come here and we can refresh this page because this has all been filled out now. So yeah, now we can see that stage 4, this has been filled out, and then all of this talking about each of the steps as I mentioned. The other thing that we can do is we can come up to our LLM monitor here, do this request here, and then draft pull request, which is what we want. We don't want the we don't want an actual pull request. We want the draft one. Now, what do we want to call this? I'll say adding observability and telemetry, observability and telemetry gathering. Sure. Okay. So draft, yeah. All right, there we go. Now, the really good thing about this is we can just come here and go to Files Changed, and it gives us all of the things which are different. So we can easily track what was changed and what was what still needs, or what was changed and what we need to investigate. Okay, so here we go. It is writing this, and there we go. So let's, right, well, so let it finish, and then we'll push it out, and then I will then be able to come here, and then we'll be able to see it. So, are you done? Cool. So git add, git commit. So created concepts document for 002 implementation review. Okay, there we go. And push you out. And now I should be able to come here, and this is going to be in document. I need to make sure that I'm on the correct one here. Concepts document and this one. So I will now need to go in and go through, let's see how, let me move myself over here. Need to go through all of this, okay? Yeah. Try to understand everything in here, then compare the code, then look at what it did, and then we can finally merge things. Test it, make sure it aligns, and then we can finally merge it. So there's a lot ahead of us, but it is a really good step. I think we made a lot of progress. I think we are on the right track. And as I've said in this video, that observability was one of those things that I really feel that I need to be able to get a really good grasp on and learn about to be able to become a professional software engineer. So it's very good that I'm able to have an opportunity to be exposed to it, or to force myself to be exposed to it in personal projects so that I can grow in that dimension that I really want to be. So yeah, I'm going to go and try to read through this, understand it, and then I have some others like stuff that I'm trying to understand as well. So just like random other engineering concepts that I'm like, oh, I'm curious about how this works. So I'm going to go and study it. And then once I'm able to get a better handle on it, then we can go and do the next video, which is going to be the code review of it and then merging it in. So yeah, thank you for watching this video. If you liked it, subscribe and we can continue this together. My name is Timothy Lee Grant, and I will see you in the next video.